everyone, welcome to second part of four set Venn diagram. My name is Ravi Prakash and we'll be continuing from the last video only. Okay, so last video we ended the last video at this point where we discussed about this question. Now we'll move to third question, right? We'll move to third question in this set. Okay, see third question now. Now, if the number of students playing TT is more than any other sport, then find the least number of students playing TT. Correct. Now, very important concept of, we'll discuss a very important concept here of distribution. Right? We'll discuss a very important concept of distribution in this set. Distribution. Okay. So, through a question, we are discussing a very important concept of distribution, which you can apply in numerous of other questions, right? Now see here. If the number of students playing TT is more than any other sport, how many are playing TT here? We've done it already. C plus 156. Okay. So C plus 156 is more than any other sport. So what I have to do basically in this question now? See, now we have all this data here, right? We have all this data here, and same written here also that question 3 and question 4 are on distribution concept of maximum but minimum and minimum but maximum. This is minimum but maximum. We'll discuss it, right? We'll discuss it here. See, or what we can do, we can just read it so I can convert here. Put badminton here. So how much is badminton? So we just calculate, right? Badminton we have calculated this whole circle of badminton. Okay. It was D plus 167, right? So see, now I have to make this number of students playing TT is more than any other sport, right? So I have to do? I have to maximize it. Understand this concept, right? I have to maximize it, right? But then find the least number of students playing TT, right? Then find the least number of students playing TT. This is also right. So these two are, if you read these 2 points together, find the maximum number of students playing TT, but that number should be least also, right? So these two looks contradictory, right? But what is the case actually? You have to find the case when you have to solve this question, like you have to give TT the maximum number of playing, right? Maximum number of students are playing table tennis, but that number is as less as possible, right? For example, suppose I tell you A has got 10 chocolates and B has got 15 chocolates, right? Now you have got 17 chocolates with you, or let's say take a small number, right? Just for understanding it is, or just take, suppose you have got 7 chocolates. You have got 7 chocolates with you, and you have to maximize the number of chocolates with A. You have to maximize the number of chocolates with A, but I tell you that number should be as least as possible, as less as possible, right? So what we'll do basically, suppose you have 7 chocolates, right? So what we'll do, so you can give all 7, right? I want to increase this number actually. Okay, let's make it 10 chocolates. Okay, you have 10 chocolates. A has got 10 chocolates. B has got 15 chocolates. You have got 10 chocolates, right? So if you have got 10 chocolates, you want to distribute these 10 chocolates among A and B. Distribute these 10 chocolates among A and B such that A gets maximum, but that number should be least. That means that is the case of maximum but minimum. Okay, so what A wants is maximum but minimum, right? That means A should be more than B. Right? But that number should be as less as possible. That means in one case you can give all these 10 chocolates to A. So if you can give all these 10 chocolates to A, so A will have 20 chocolates. That's fine. A is more than B. Right? But that number is this is number 20. This number 20 is not satisfying the condition. This is not a least number possible. This is not the least number possible, right? Which is the least number possible then? So how to distribute? So you should give some to B also, right? So suppose what I'll do in this case, I have 10 chocolate, right? So I'll give first 5 to A, right? So in first case, I'll give 5 to A. And both I'll make 15. Both are now 15. I've given 5 to A, so I'm left with 10 minus 5, that is 5 chocolates. I'm left with 10 minus 5 chocolates. So I'll keep making them equal, right? I have 5 chocolates, still I can make them equal. So I'll give 2 to A, I'll give 2 to B. So they each have now 17 and 17. And I've given away 2 plus 2, 4. So 5 minus 4, I'm still left with 1. I'm still left with 1, right? Now, one chocolate, since I have to give A maximum number of chocolate, that means A should be more than B. So I should give this 1 to A. So at last, A will have how many chocolates? A will have 18 chocolates. So A has 18, B has 17. So A is more than B, but that number is as least as possible or as less as possible, right? This is the meaning of maximum but minimum. Or this what language this question says, right? If A gets more than B, find that least number possible, right? So if I have given all those 10 chocolates to A, then A would have 20 chocolates, right? That's correct. A is more than B, but that number with A is not as less as possible, right? I can further reduce this number from 20 to what? 20 to 18. I can further reduce this number from 20 to 18, right? So 18 is that greatest number possible, right? Hope you got this concept, right? So very easy concept it is, just a bit confusing in wordings, okay? That if 2 or 3 people are suppose among 4 people, if I have to give the maximum, if I have to get the maximum number of chocolate, okay? So it's a one way. Suppose I take all the chocolates available, right? So I'll be maximum, but I should have maximum number of chocolates, but that number should be as less as possible. That means how to distribute? Distribute equally till last moment, and then if you have 1 or 2 chocolates in hand, you can easily calculate it, right? One more example I'll do. One more example I'll do, right? So very important concept. One more example I will do. Then we can solve this question. It will be third example for this concept. Then you can understand it easily. Now see, this concept here is suppose A has got 7 chocolates, B has got 10 chocolates, and C has got 8 chocolates, right? What you want is you have got 20 chocolates in your hand. You have got 20 chocolates in your hand. You want to distribute these 20 chocolates to A, B, and C such that C gets that maximum but minimum number. C gets that maximum but minimum number. That means C should have the maximum number among all three, but that number should be as less as possible, as least as possible, right? So what we'll do? What we'll do? First we'll make all these numbers equal. First we'll make all these numbers equal, right? That means I have 20 chocolates. I'll suppose B has got 10 here, so I'll give 3 to A and I'll give 2 to C. Now all three have got 10, 10 and 10 chocolates with them. How many chocolates I am left with? So I had 20 chocolates. I have given away 3 plus 2, 5. 20 minus 5. I am left with now 15. I am left with now 15. Right? Now I have to keep them distributing equally till last moment, right? But here it is 15 and distribute among 3 people, so I can't distribute 5, 5, 5 because all will get equal and my chocolates will be finished. So I can't do like that, right? I have to keep some number at the last so that I can distribute. Okay, that means I should make them equal till the last moment, but I have something in my hand, either one chocolate or 2 chocolates or 3 chocolates, right? Then I can distribute easily. So if this is 15 chocolates, so I should not give 5, 5, 5, but I should distribute equally. So the next best number is 4, 4, 4. So I should give 4, 4, 4 to them. 4 chocolates, 4 chocolates, 4 chocolates. Now all have got 14. All have got 14. And I am left with 15 minus 12. 4 plus 4 plus 4 is 12. I am left with 15 minus 12, that is 3. I am left with 3 chocolates now. Right, so I am left with 3 chocolates now. Correct? Now all are equal. I am left with 3 chocolates now. Okay, so I am left with 15 minus 12, 3 chocolates. I am left with 15 minus 12, 3 chocolates, right? Okay, 15 minus 12 is 3 chocolates I am left with. So how to distribute now? Again, I want to give C maximum, right? But if I again give all three chocolates to C, if I again give all 3 chocolates to C, C will have 17. That is a maximum number. That number will be, not minimum. I want maximum but minimum. That means maximum, but that number should be as least as possible. So I should not give all 3 to C. I should not give all 3 to C. So what I should do then? Out of these 3 chocolates, what I should do then? I should give 2 to C and any 1 to the other people. So that in the last, when I'm finished, 3 minus 3 is 0. I am left with no chocolates. C has got 16 chocolates, B has got 15 chocolates, and A has got 14 chocolates, right? 14, 15 and 16. This is the distribution. From when we started, A had 7, B had 10, C had 8, and I had 20 chocolates. to distribute to them such that C has the maximum number among all three, but that number is as least as possible. So I could have given all the 20 chocolates to C, right? Then C would have become 8 plus 20, 28. Then C is the maximum of all these three already, but that number is not minimum. That number is not minimum, right? That there is further minimum number possible, which is that number 16. Still, still C is maximum among all these three, right? But C is 16 is that minimum number possible, right? That means 16 would be the answer for question. What is the maximum but minimum number can be given to C? That could be 16, right? So this is a concept of maximum but minimum, or it can be given in this language that find the maximum number possible. Find the maximum among all three for C, which that number is as least as possible, right? This is the whole concept behind distribution, maximum but minimum, right? In the next question, we'll do minimum but maximum also, okay? So important concept of maximum but minimum. So and what we are doing here is one should have maximum number, but that number should be as least as possible, as less as possible, right? Okay, now come to this question. Now you can do this question easily. So I would give a question is, if the number of students playing TT is more than any other sport, if the number of students playing TT is more than any other sport, okay, that means TT has to be maximum, but then find the least number of students playing TT. Then find the least number of students playing TT. Okay, so find the least number of students. That means I have to find what? Maximum but minimum. Maximum but minimum for TT. We have to find maximum but minimum for TT. So very important concept is maximum but minimum for TT. So how to find it now? Maximum but minimum for TT. How to find it now? See. So we have these variables here. D plus, so let me write all these variables here, right? Cricket is how much? So cricket is A plus 163, correct? Hockey is B plus 180. Then TT is C plus 156, and then badminton is D plus 167. Badminton is D plus 167, right? Now, you know that TT has to be that in that funda of maximum but minimum. Okay, maximum but minimum. TT has to be in the funda of maximum but minimum. That means I should distribute such as TT should get maximum but minimum number. So how to distribute now? So we have the variables like A plus B plus C plus D here, right? And I know that A plus B plus C plus D is 123. This scenario is like viewership of cricket. Sorry, students liking cricket is how much? 163 right now. Students liking hockey is 180. Students playing TT or liking TT is 156, and students playing badminton is 167. It is 167, right? Now, and total we have A plus B plus C plus D left with us, that is 123. So total we have 123, which should be distributed among all these three people. Total we have 123, which should be distributed among all these people. 123. A plus B plus C plus D is 123. So it's like 123 chocolates to be given to C, H, T and B. Already they have 163 chocolates, 180 chocolates, 156 chocolates and 167 chocolates, right? I have to give 123 chocolates to them so that TT gets the maximum number. This question is same as that, right? Okay, I hope you can connect it. So what is the first funda we'll do? Firstly, we'll make all the numbers equal. I'll make all the numbers equal. How to make all the numbers equal? So give, right? So what is the maximum number here? Maximum number here is 180. So make all equal to 180. So for making all equal to 180, you give 17 to C, right? You give 24 to TT, and you give 13 to badminton. How much it is now? All have got 180. All have got 180, 180, 180, 180. How many chocolates I'm left with now? So 17 plus 24, 41 plus 53, 41 plus 13, 54. So 123 minus 54. I'm left with 69 chocolates. I'm left with now 69 chocolates, right? Now again, I'll make it equal. So again, 69 to be divided in 4 parts, right? 69 by 4, 17. Okay. So I'll give 17 to each. 17 plus 17 plus 17 plus 17, right? So all becomes 197. All becomes 197, 197, 197, 197, right? 17 4 is 68. So 69 minus 68. I'm left with one chocolate. I'm left with one chocolate, right? That one I have to give to whom? To TT, right? That one student I need to give to TT, right? So that TT becomes maximum. That becomes maximum. It becomes 198. See, it is 198. It is 197. It is 197. And this is also 197, right? So you can see here, this is just maximum or maximum but minimum. So what is the question? Number of students playing TT is more than any other sport, right? It is more than any other sport. All other are 197, 197, 197. TT is how much? 198. But that number is least number. Find the least number of students playing TT. This number is as least as possible, right? This is called maximum. It is called maximum but minimum, or in normal language you can call it just maximum, right? This is right. This is GT is just maximum, just more than 197, just maximum or maximum but minimum. Or the language can be find the maximum number of students playing TT if that number is as least as possible. So find that least number of students. Okay. So very, very important funda, very, very important funda we have discussed here. What is the answer for this question? Answer for this question is 198. Answer for this question is 198. This is the right. They're not given options here. In the CAT these days, right? Many questions are subjective, many are objective. Options will be there, will not be there, right? It doesn't matter, right? You have the concept. So answer for this question is 198. A beautiful question, right? This is a very good question. If you get this set, no, right? I'll spend 1 hour on this set is on explaining this whole concept, right? You get this 1 hour completely devoted to this set. You'll not only learn about four-set Venn diagram, but the Venn diagram concept, distribution concept, maximum minimum concept. So many concepts are clear with this one. You spend 1 hour, right? This 1 hour is worth spending. You can apply this concept in many other sets. Okay. And by side we are learning Venn diagram also, right? It's a master set. Okay, I hope it is clear, right? I hope it is clear. This set I created for one of the mocks. Okay, so that's why I've discussed it. Okay, one of the mocks. So I've given all the 4 questions. Very good questions, right? I've added one more question because generally in CAT we have only 4 questions, but we have given one more question at the start. Okay, just to add a new dimension to it, right? So it's a very nice question I created. So that's why you've discussed here. Okay, now we will see it for next question, right? Next question. See here now. Next question. If the number of students playing badminton is least among all the other sports, if the number of students playing badminton is least among all the other sports, right? Now, this time badminton has to be in the least part. Badminton has to be in the least part. Badminton has to be in the least part, right? But find that maximum number possible. Right? There is a concept of again distribution concept, but it is what? It is just reverse of it. Minimum but maximum, right? That means what? If the number of students playing badminton is least, it is least and it is minimum, but find that maximum number possible. So that is maximum. So minimum but maximum, right? So again I'll explain this funda with a chocolate concept, right? See here, you can see it by chocolate concept. See, suppose A is having 6 chocolates, B is having 9 chocolates, and C is having 5 chocolates. Okay, and you have let's say you have 19 chocolates with you. You want to distribute these 19 chocolates among A, B, and C such that C gets the minimum number. That number should be as maximum as possible, right? So another one way is if only it was minimum. So if C gets minimum number, so quite easy for me. I'll give all these 19 chocolates to A or B, and minimum number is C for 5, right? That's the answer. But this question is for minimum but maximum. But that number C should be minimum, all right. But after distributing this 19 chocolates among A, B, and C, that number with C should be as least as possible. Sorry, that number with C should be as more as possible, as maximum as possible. So again, the funda will be same, right? We'll make it equal till the last moment and we'll see in the last. Okay, we'll make it equal till the last moment and we'll see in the last, right? So let's make it equal now. Okay, so if I have 19 chocolates here, so it is 9 is the maximum number here. I can make it all equal to 9. That means I can give 3 to A and I can give 4 to C. How much it is now? All have got 9, 9 and 9. I am left with 19 minus 7. 4 plus 3, 7. I am left with 19 minus 7, 12 chocolates. I am left with 19 minus 7, 12 chocolates. Correct? Now, again, I want to distribute to them, right, till the last moment. Okay. So, I should not give 4, 4, 4 because then all will be equal. So, I should give next best number is what? 3, 3, 3. So, I should give 3, 3 to all of them. 3, 3, 3, 3, 3, 3. So, 12 minus 9. 12 minus 9 is how much? 3 now. So, I'm left with 3 chocolates and now all have 12 chocolates. Right? Now I can do it easily because this number is 3 here. I should do it least, right? I have to make it least this number. So what I should do here is I have to make C least, right? I have to make C least, minimum but maximum. So what I should do here is these 3 chocolates I should give to distribute like 2 to A and suppose 1 to B, or all 3 to A, doesn't matter, right? All 3 to A. That means these 3 can be distributed like 14 to A, 13 to B, and finally 12 to C. That means you can see here, question satisfied. What I wanted is C should get minimum number. Still C is getting minimum number because A is getting 14, B is getting 13, and C is getting 12, right? But that number is as maximum as possible, as more as possible, right? That maximum number can C get 12 and still C has the minimum number in among all the 3 people, right? So maximum number C can get is 12, still C has the minimum number among all these 3 people. That this is the case of what? This is the case of minimum but maximum. Or you can write it as general language just minimum. Right? C just minimum, right? 14, 13, 12. C just minimum. Okay. Or in language you can write like this. Find the number of chocolates with C such that it is least among all A, B and C, but find that maximum number possible, right? So case of minimum but maximum. Right? So I hope you got this concept now. If you got this concept now, we can do it very easily now. You have to do it very easily. We can do it now. So what I want now? I want least for badminton. I want least for badminton. And what data I have? Again, same thing we'll discuss. Suppose cricket has it is given that cricket has A plus 63. So again, I'll take A and B out of the equation, right? I'll take A and B out of the equation because I know that A plus B plus C plus D, right? I know that A plus B plus C plus D is how much, right? So this data is, I can do it easily here. How much is C? So C is, suppose cricket is 163. Suppose hockey is now B plus 180. So it is 180. Suppose table tennis is now 156. And suppose badminton is now 167. Take this A plus B plus C plus D out of equation. And I have A plus B plus C plus D is equal to how much? Is equal to 123. So same thing. I have 123 chocolates in my hand, right? C has got 163, H has got 180 chocolates, T has got 156 chocolates, and B has got 167 chocolates. I have to distribute these 123 chocolates among these 4 people such that B gets that minimum but maximum number possible. Minimum but maximum number possible, right? So just we'll do like this. Again, same thing. We'll make all equal. Right? So we'll make all equal. So see here, how can make all equal is, since C is 163, so maximum number here is 180. Funda is same, right? Maximum number is 180. So make all equal to 180. Give 17 to C. Give 24 to T, and give 13 to B. Now all have 180, 180, 180 and 180 with them. How many I'm left with? 17 plus 24, 41 plus 13, 54. 123 minus 54. I'm still left with 69, right? Now see, just a small precaution here than the last step, right? Now if you divide it like this, as in the last step what we did, if you divide like this, right? If you divide like this, that 54, that 69 is now the number, and if 69, right? If 69 is to be divided by in 4 people equally, so 69 by 4 is 17. 69 by 4 is how much? 17. So 69 by 4 is 17, right? But if you give 17 to all the people, see here, if you give 17 to all the people, so you are only left with 1 chocolate at the last, right? That one you have to give to anyone, but still B is 197, T is 198, or anyone like H is 197 and C is 197. So you can see it, badminton is not minimum here. Badminton is not minimum here, right? Because others also have got 197 and 197, right? So others also have got 197 chocolates. Badminton not minimum here. Badminton is not minimum here. That's why, to avoid this kind of situation, what we'll do is, in case of minimum but maximum, have one more chocolate in hand, right? So let's 17 is not that good number, right? So what I should do here, next best number is 16. So I should give 16 to everyone. So I should give 16, 16, 16, 16, right? All becomes 196, 196, 196, and 196, right? And 16 4 ja 64. So I'm left with 5 chocolates now. Now I'm left with 5 chocolates, right? Now see, among these 5 chocolates, if I give, right, if I give any one, understand the situation, right? If I give any one chocolate to B, right? So if I give one chocolate to B, what will happen? So if I give one chocolate to B, in that case, I'm left with 4 more chocolates, right? I'm left with 4 more chocolates. So how to give those 4 more chocolates? I can give this one to TT, and one to H, and suppose two to C. It doesn't matter, right? But I can give one chocolate to B, but I can't give 2 chocolates to B, because in the second case, if I give 2 chocolates to B, so if I give 2 chocolates to B, so B becomes 198. So if B becomes 198, then other should be 199. So for 199, they should also get 3. They should get 3 each, right? But I don't have 3 into 3, 9 plus 2, 11. I don't have 11 chocolates, right? I have only 5 chocolates. That means what I should do is just give B one more. Just give B one more. Just give B one more, right? So give one more to B. B will be with 197, right? Now all can be made 198. Is it possible? Let's see. Understand the situation. If I give 1 to B, then B is now 197. So can I give, so I have to make all 198 because B has to be minimum. So at least one all has to be 198. So can I make all 198? So for making all 198, I should give two here, 2 here, 2 here at least. So 2 plus 2 plus 2, how much? 6 more needed, right? 6 plus 1, 7 more needed. I don't have 7, dear. I don't have 7. I have only 5 chocolates. That means I can't give any one chocolate to B. I can't give any one chocolate to B. So what is the answer in that case? If I can't give any one chocolate to B, that means for B it is finished, right? For B it is finished. Answer for B is how much? Answer for B is 196. That's it. Now this 5 you can distribute. You can give like 2 TT, or 1 here, or 1 here, right? It's okay. You can distribute all these 5 chocolates, or 2 here, right? So that means in the last cricket has got suppose 198, right? Cricket has got sorry, it is a plus sign here, should be equal to sign here. Now cricket has got 198, right? So cricket has got 198, hockey has got 197, TT has got 198, and badminton has got 196, right? This number is what? This number is less than all the other numbers. This number is less than all the other numbers, but that number is least number possible. Least number possible when badminton, least number possible when badminton is played by less people than all other sports. Okay, so this is the least number possible when badminton is played by less people than all, or I should, sorry, reverse. Sorry, it is reverse here. This is the maximum number possible. I should write it. This is the maximum number possible. This is the maximum number possible when badminton is played by less people than all other sports, right? So see here, what is cricket? Cricket is how much? Cricket here is 198. Hockey here is how much? 197. Okay. How much is TT? 198. How much is badminton? 196. So it is less than all the other sports, right? But it is a maximum number possible. That was asked by question, right? In the question, if the number of students playing badminton is least among all the other sports, find that maximum number possible. That maximum number possible can be how much? 196. So 196 is the answer for again this very nice question. So very good concept we have discussed in these two videos, like this four set Venn diagram. I really think that if you understand this this four set Venn diagram with all these concepts, right, you can apply it in 20 more sets. So if this one set is equivalent to 20 other sets, right? So learn this concept, and we'll keep doing this kind of concepts in another videos of LRDI. Okay. So I hope you enjoyed it. Right, a bit hectic, but kindly just watch this video twice or thrice to understand this. Okay. Ask me in case of any doubt in the forum. Okay. Thank you.